The case progressed by right pleural effusion, then bilateral pleural effusion very fast, and this is the CT after some time. And the back pain was attributed to this lesion here, which is the metastasis. Okay. This is not working well. I can see the pointer here. Okay. So it is 5, 4, 3, 2. If you want to have a look down, count from down, it is L2 shows a metastasis. But what I want to point out to you that if you are doing spine imaging, don't look only to the spine. You have to look outside the spine, especially if you find metastasis. And if you look here, you'll find many things which are bright and anterior to the spine in T1, and they are correspondingly bright on T2, so this is fat. But look at the pelvis and you'll find that what is bright there in the pelvis is not correspondingly bright on T1, so this is not fat, this is fluid. And you have to pick up pelvic peritoneal recess fluid on MRI of the spine because it is a very important sign. And it led to the diagnosis of ovarian carcinoma in this case. After finishing the spine and looking at this, we had to open the field of view and look at the ovaries, and we found the malignancy. So here you have a parasagittal image of the right ovary and is normal, and the left ovary and contains the and it contains a big mass which is a primary malignant neoplasm. It proved to be choriocarcinoma, again very unusual histopathological feature in the ovary, an absence of the line of the trophoblastic disease. So it is in the pediatric age group, 13 years, and the metastasis this time is not like the other time. This is a conventional metastasis. You see it bright on T2, a little bit bright, a little bit hypodense on T1, enhancing and peripheral washout. This is the typical peripheral washout sign of metastasis, and it is a parenchymal metastasis of choriocarcinoma. So keep in mind, the first case was an intrasinusoidal metastasis of choriocarcinoma. This is metastasis in the parenchyma, and typically shows restriction of diffusion, and typically there is also adrenal metastasis. You can see it here, and you can see that it does not drop comparing the in phase and out of phase, and it shows also restriction of diffusion. So this is a perfect case of metastasis everywhere from choriocarcinoma of the ovary in a 13-year-old child. Again, what we learned is that choriocarcinoma may occur outside the spectrum of the gestational trophoblastic disease. It may present initially by lymphatic carcinomatosis of the lung. And again, we learned from this and the first case that ovarian neoplasms are clinically hidden. They don't come to you, you have to go to them. And the spine is a very good way to find the ovary sometimes. This is a patient with vaginal bleeding, and it is not a quiz, it is very easy case of cancer of cervix. This is the washout and the delayed post-contrast, and this is the picture of the T2 weighted image. It is a malignancy of this uterine cervix. What I want here to stress is a message I gave in the same room here 1 year ago about the diffusion weighted image and enhancement and the matched restriction and enhancement. It is not enough to have diffusion restriction to say we are dealing with something bad. It is not enough to have enhancement on the gadolinium image. We have to have matched enhancement and restriction of diffusion. This case illustrates the situation very nicely. We have two spots of restriction of diffusion. This is the cancer of the cervix, but this is not a metastatic lymph node because you'll find that it is not enhanced. This is the enhancement, pre-contrast, post-contrast, enhancement of the cervix cancer, no enhancement of this, it is edermoid. It is showing restriction because it has thick contents. So matched enhancement and restriction is important. And adding to this, FDG uptake. And you know that PET MRI is in the way and already used in many parts of the world. CT will give to the PET a good localization, but only an anatomical localization to say, fine, this is the same location here or so. But MRI PET will show you additional value, and here if you add to the matched enhancement and diffusion restriction, the matched uptake of FDG, and in this case you'll be very confident in diagnosing metastasis, malignancy. So here is the cancer of the cervix. It is not a big deal here, but if you are dealing with peritoneal deposits, for example, here or here or here, and you find uptake of FDG which is like this, and diffusion restriction which is like this, and very subtle enhancement, but if you put them together, you may reach a good conclusion. So this is the details of the dermoid. It is perfect, the dermoid on CT also, no difficulty in its diagnosis, but it conveys the message. You have to have matched diffusion restriction and enhancement and FDG uptake to have confidence in malignancy. Here are some examples. This is a patient with vaginal bleeding. Again, it's very easy diagnosis of exophytic cervical carcinoma, and this is the enhancement. Now we can fuse the images, and I have seen excellent images done by one of our colleagues, Sherihana, remember, very good. So we are having this now with a blue background and yellow to red diffusion restriction scale, so you can see that we are having a matched restriction enhancement. This is a case of a fibroid, thought to be, and it is very irregular and heterogeneous. Is it degeneration or malignancy? You add the diffusion to the enhancement, and you find that you have in this part matched diffusion restriction and enhancement proved to be a leiomyosarcoma. The rest is enhancing but not restricted, which is the remaining part of the original leiomyoma. So this tells you enhancement plus diffusion restriction is malignancy. Enhancement without diffusion restriction is benign solid lesions. No enhancement and no restriction. This is a cyst with simple fluid. No enhancement and restriction. This is an abscess. So you have the combinations here, and it is a good rule to follow, but it has exceptions. So case 9 is one of the exceptions, and it is a good example of correlative thinking in imaging. You have now so many modalities, but the good thing is that you can put them together to reach a final diagnosis. And putting them together, we have here restriction of diffusion in this right adnexal mass. It is not very strong, something like just below the 1000, just at the borderline, but still we consider it restriction. You should not have that in a benign, if you have a facilitated diffusion, you shouldn't have that appearance. And besides, on the B800, it is still seen, so we have some degree at least of restriction of diffusion. And we have enhancement. So restriction plus enhancement equals malignancy. The answer is no here, because of many things. First, we have a very well-defined interface between the fluid inside and the fleshy part of the lesion, which does not happen in malignancy. This is something which is benign. Second, this is again seen on ultrasound. Second, we have a CT without contrast, and if you look at this lesion malignancy in general, on unenhanced CT, and this is something not everyone knows, but it is valid. if you measure the unenhanced scan, the malignancy, you'll find that they are far less than the muscles. Only even visually here, you feel that this is originally hyperdense lesion on CT. And if you measure, you'll find that something like 50 Hounsfield unit, and it has a small spot of calcification. So if you put all these things together, what is bright on the unenhanced CT? Things which contain iodine, things which contain iron, things which contain calcium. We don't have calcium here except for this small spot. And why should we have iron? The MRI is against that, I'm sorry. So we have iodine. So we may think here of thyroid tissue, and going back to the MRI, we may put this as immature teratoma containing thyroid, the so-called struma ovarii. This was a very daring diagnosis. We did it and it worked. It was proved histologically that this is a struma ovarii. What you can do is you correlate. If things go in certain way with some modality, then you go to the other and try to put a piece here and a piece there to reach your diagnosis. Correlated thing. This is a case which has been poorly managed. I presented the first case which was poorly managed from the radiological point of view, and this one also. We have the hyperplasia of the endometrium. It is thick and contains cysts and is hyperechoic. And we have a mass in the left ovary which is solid with a well-defined cystic, eccentrically located cystic lesion. It was not correctly described by the radiologist. This was day 1, and so the patient went to conservative management and follow-ups. This is month 2, and you can see that the hyperintensity, hyperechogenicity of the endometrium is less, but you still have the cystic areas. And you see loss of the boundary now between the outer part of the endometrium and the transitional zone. You see the solid part of the mass is bigger, the cystic part of the mass is bigger. If anyone wants to say the diagnosis, please do. This is month 7. You can see again the endometrium is less hyperechoic than before. But at least we learn from this neglected mass the natural history of this disease. And you start to see certain spots of echodoppler in of Doppler vascularity in the myometrium, and this is ushering adenomyosis. You'll see a spot of adenomyosis later on. And again, the solid mass of the left ovary is enlarging, and this is year 3. So the cysts are increasing, the solid mass in the left ovary are increasing, and here you have a well-established adenomyosis spot in the myometrium. So which ovarian mass will cause adenomatous, which causes endometrial hyperplasia? There. So it's a very easy diagnosis to make, but you have seen that it has been missed for 3 years. And in spite of that, there is no metastasis. There's not a message for you to neglect granulosa cell tumor, but it is a message that it is one of the slowly growing neoplasms. It certainly should not be missed, because the hyperplasia of the endometrium is not the only thing which can happen to the endometrium. You have the endometrial carcinoma on top of the granulosa cell tumor. But again, here let us go back to the diagnostic science. You have thickening of the endometrium, but you have cystic spaces, and I find these cystic spaces very important. You see they are subendometrial here, 2 spots of cystic spaces. There are some cystic spaces in the endometrium itself, but you don't see them because the endometrium is bright and they are bright. And the lesion is solid with cystic components and enhancement and restriction. So enhancement plus restriction equals malignancy. This is a case of granulosa cell tumor. I brought to you a couple of granulosa cell tumor to fix the message of the endometrial appearance. This is a solid mass of the right ovary. And this is exactly, again, you have thickening of the endometrium and subendometrial cystic spaces, and some myometrial cystic spaces as well. And this is the mass, and this is the restriction of diffusion in the mass, and this is the enhancement. But I'm adding here that there are hemorrhagic foci within the lesion from the unenhanced T1-weighted fat-saturated energy. This was also present in the first case. I didn't point out, but it is a very good feature of granulosa cell tumor. You have hemorrhagic spots in the T1-weighted fat-sat before injection of contrast. This is the third case of granulosa cell tumor. You see now perfect adenomyosis, because like the endometrium is hyperplastic, the endometrial islands within the myometrium go also hyperplastic under the effect of the secreting tumor in the ovary. And this tumor in the ovary has cystic spaces and has hemorrhagic foci, and you have the cystic lesions here in the subendometrial space. So a perfect case again of granulosa cell tumor. This is one more case, and you can see here, because of the type of the T2, which is not increasing the endometrial signal very much, you can see that there is difference between the cysts and the endometrium itself. So this is the cystic lesions within the endometrium, in a case of granulosa cell tumor, and this is the mass there. So a very big number of granulosa cell tumor. To fix the message, here you have the hemorrhagic foci. The hemorrhage here as at the periphery, and we'll know in a second why. And the enhancement is, no, it's not enhanced. So this is the T1 weighted, and this is the fat sat T1 weighted. And you see that this line of high signal intensity is there because it is hemorrhage. And enhancement is very poor. If you look at the post-contrast here, you don't see any enhancement. And why? Because there has been torsion. And this takes me to the next message I want to give to you now. And when you find torsion in one of the ovaries, please look at the position of the cervix and the lower uterine segment. You'll find that they are shifting to the same side of the torsion. This is a sign not everyone knows, and probably it is not written in books. So what happens is that torsion is twisting, and this twisting pulls on the broad ligament on the same side. So it takes the lower uterine segment and the cervix to the same side like the mass. I'm saying this because the mass could be on the other side, but you'll see that the cervix is going to the side of the mass. So take care. There will be discussion of the torsion now in the next few cases. But to sum up here, you don't have enhancement of the granulosa cell tumor because it has suffered torsion, and you know that it is torsion, although it is still on the same side, because sometimes it twists, sometimes it flips, and you have seen a flipping tumor with the first signet ring tumor. It has not twisted, but was just on the lateral side and became in front of the uterus. And I said to you that the position of the tumor in front of the uterus is something which not very pathognomonic or specific, but lets you think of ovarian torsion. Be aware of the shift of the cervix to the same side in cases of torsion. This is the endometrium after removal of the mass returning back to normal. So this is a group of cases with granulosa cell tumor. We learned that endometrial hyperplasia or small cysts, which are endometrial, subendometrial, or even myometrial, is a good sign to make the diagnosis. And the granulosa cell tumor may behave less aggressively, as we have seen in the first case, which has been neglected for 3 years. Again, I'm repeating, this doesn't mean that you neglect it. And the granulosa cell tumor shows small hemorrhagic foci and well-defined cystic lesions to distinguish it from the ill-defined cystic structures, which happen as cystic degeneration in more aggressive ovarian tumors. Unlike all ovarian masses, you have to go to them. Don't wait for them to come to you. You have to search for ovarian masses actively. Well, now we have a discussion about torsion, and we have again a lesion which is in front of the uterus. Lesion in front of the uterus, think torsion. This lesion has been taken out and proven to be borderline mucinous neoplasm of the ovary. This is not our story now. But our story is that sometimes you diagnose ovarian neoplasm, but you don't know which one. So you say, this is ovarian neoplasm of unspecified site. And this may let others joke at you. You don't know your right from your left. Yes, it is difficult. It is not only for the juniors, it is difficult for everyone. Sometimes if the ovary is in the middle line or on the other side, to call it left, and in fact it is right. So why is that? Because sometimes you don't see the other ovary. The best clue to know which ovary is giving the neoplasm is to find the other ovary. But sometimes you don't find the other ovary. You know that in ultrasound there is a percentage of finding it. On CT there is a very poor percentage of finding it, especially in old age, 60 years or more. And on MRI sometimes you find it, but MR is the best performing of all. Why? Because you know the ovary by first, relation to the cornu of the uterus on the same side. Second, relation to the ligamentum teres of the same side. The ligamentum teres is very close to the ovary, and it goes and travels to reach the inguinal canal. So you can take it from the inguinal canal and replace. Sometimes it does not lead you to the ovary, but most of the time it leads you there. Then third, the ovarian vein. And if you inject in contrast in the post-contrast gadolinium, you see the ovarian vein enhance it, you can trace it up, you reach on the right side to the cava and on the left side to the left renal vein. So this is also again a good landmark to not only to find the other ovary, but it may lead you to the mass. I mean, you can trace the right ovary and you find that it is going to the left and the mass is on the left. So this has helped me a lot. So again, we have the cornu of the uterus, we have the ligamentum teres, we have the ovarian vein. These are structures which lead to the ovary, so you can identify. But in the ovary itself, you have the follicles. In MRI, you have the follicles. If you find the follicles in a structure, but don't mislead yourself with small cystic structures which are not that. The follicles are important. And the last thing, and also is very important, is the diffusion weighted image, because the ovary has some little restriction on the diffusion weighted image. So we'll see example of that. This case has been removed, and the surgeon sent it to the pathologist, ovarian mass of unspecified size. So things are difficult for them as well. But on the MRI, which has been done before surgery, we can see the ovary, only the surgeon was not aware of that. So this is the transverse MR, this is uterus, this is mass, and this is ovary. Why this is ovary? Because of the follicles. And you can see this also on the contrast study. This is uterus, this is pelvic fluid, this is perfectly the normal ovary, which is the right, so this is the left. And it is not enhancing because it is in torsion. So the message here is that the best clue to know the site from which the tumor is coming is to find the other ovary. And we said how to do that. This is again lesion in front of the uterus. It is a dermoid. Never mind that. We are discussing now the sites. So lesion here is probably in torsion. And here we have it more on the left than on the right. And here we have a left ovary. This is a perfect left ovary. So the solution is easy. But again, I'm pointing your attention to the position of the lower uterine segment. You may think that this is pushed by this mass to this direction, but no, we have seen a torsion which remained on the same side, and it is not because of push effect, it is a pull effect. The torsion, the twisting of the broad ligament will take the cervix and lower uterine segment to the same side. So this is the diffusion restriction in the dermoid cyst. Never mind that, we have spoken about it, but look at the ovary. The ovary is there, it is there, it is there, and it is showing some restriction of diffusion. Don't look at the ADC in case of the ovary, look at one of the steps in the middle. So we do usually more than one step, and you can see the ovary in these cases. So it is a very good way to identify the ovary, the diffusion-weighted images. And here again, the same case, you see the normal ovary on the left. You don't see the mass because this is the coronal behind it, but look at the position of the uterus. This is not a pushed uterus, it is a pulled upon from here. So the pull on the lower uterine segment is a very good sign of torsion, not written in books. This is again another case of torsion. The case here is benign. You see, because of the interface between fluid and the solid part is well defined, this is a sign of the benign lesion, and it does not show restriction and blah blah blah. It is a total adnexal torsion of the left side. Why? Because the cervix is going to the left side. And why again? Because the ovary on the right is normal. So this is the normal right ovary. This is the lower part of the uterus pushed to the left, pulled to the left. And this is the torsid mass, which is a left adnexal mass. Again, this is the coronal of the same case. And here is the normal ovary. And here is the cervix. Sorry, don't see it. No, yes, this is the cervix. This is the rectum. This is the sigmoid, this is the cervix, this is the ovary. So how close to the pelvic wall you see the cervix is? It's because it is pulled upon to this position. And this is the case, again, you don't see very much enhancement in this total adnexal portion because it is deprived of its blood supply. The message, again, is the same. The best clue to decide is identification of the other ovary, and the lower uterine segment is frequently pulled towards the pelvic wall on the same side of the torsid ovary or adnex. This is another feature of torsion, which is the presence of gas within the tumor. And this is because of the tumor necrosis. This was a very huge dysgerminoma, and the presence of gas here is a sign of torsion. This is CT without, and this is CT with contrast, very little enhancement. And this is the case from the literature, showing very well the gas inside of this dysgerminoma. It is a very rare sign, but it helps you also diagnose torsion in tumors. One last case, and let us be interactive before going home. You have a mass here on the right. It is a dermoid, no question about that. The question is which ovary. So you may think it is the left ovary and it is fine, or you may think it is the right ovary and there is torsion. So please, right ovary, raise your right hand, left ovary, raise your left hand. Or who wants to comment as well? No. The key is the other ovary, yes. Yes, okay, I will point it out. Someone said it is this, but someone else told him, how can you know it can be unopacified bowel? This is the uterus. For the right ovarian vein, we don't have it. Okay, you follow it and tell me. You think it is the right ovary. Okay. Dr. Salwa thinks it is the right ovary. This is the uterus. Sorry. Uterus. Yes, but we said that it is the lower uterine segment. No, the upper is deceiving. Okay, so what do you think, Raja? Raja says left ovary, Dr. Salwa says the right ovary. Me is out. We don't have MRI. And yes, to make it easy, if you do MRI, you will lose the